All right, so for these examples, 43 to 45, I'm going to do 44, then I want you to attempt 43 and 45. Now, example 44 says, find the value or values of x satisfying the equation e to the 2x plus e to the x is equal to 12. All right, here's how we approach this. E to the 2x plus e to the x is equal to 12. Now, e to the 2x is the same as saying e to the x squared. That is just reverse application of a law of indices, reverse application of power for power. So the power inside the bracket is multiplied by the power outside the bracket. And this is plus e to the x is equal to 12. Now, if I let us say e to the x be a, my equation would now read a squared plus a is equal to 12. And now the equation would be a quadratic equation. So I need to make one side of the equation equal to 0. A squared plus a minus 12 is equal to 0. This expression can easily be factorized. We have a here, 4, and 3, plus for the 4 minus for the 3 is equal to 0. So now I have a minus 3 is equal to 0, or a plus 4 is equal to 0. Therefore, a is equal to 3, or a is equal to minus 4. Now remember, a was actually e to the x. So e to the x is equal to 3. Remember, our objective is to find out what x is. Now, e to the x cannot be equal to minus 4. Now, and I'll say why. There's no value, there's no number, no real number that x could be in order for e to the x to be equal to minus 4. The basic reason for that is you cannot raise a positive number to a power and get a negative answer. You cannot raise a positive number to any power, whether the power is positive or if the power is negative. You cannot raise a positive number, and e is a positive number, to a power and get a negative answer. So e to the x cannot be equal to minus 4. And so e to the x is only equal to 3. If I now take log to the base e of both sides, I'm going to get x ln e is equal to ln 3. But ln e is the same as saying log to the base e of e, which is 1. So 1 times x is equal to ln 3. Now, ln 3 is your exact answer. And of course, you can always put this in your calculator and get an answer which you can round to 3 significant figure. So ln 3, the 3 significant figure, x is 1.10 to 3 significant figure. X is 1.10 to 3 significant figure. All right, so let's have a go at example 43. For example 43, I have 2 to the x plus 1 is equal to 5 to the 1 minus 2x. I'm going to take ln for both sides. So I'm going to have x plus 1 ln 2 is equal to 1 minus 2x ln 5. So remember, our objective is to determine what is x. I'm going to apply distributive law to get whatever is inside is multiplied by what is immediately outside. So I have x ln 2 plus ln 2 is equal to ln 5 minus 2x ln 5. Let's get everything with x in it on one side and everything that doesn't have an x on the other side. So I have x ln 2 on the left minus 2x ln 5 come over as positive 2x ln 5, and that is equal to ln 5 minus ln 2. X is the, over to the left, x is the common factor, so you factor out x, you get ln 2 plus 2 ln 5, and this is equal to ln 5 minus ln 2. So of course, if I want, I could say that this is x ln 2 multiplied by 5 squared is equal to ln 5 divided by 2. So I have x ln 50 is equal to ln, and that's because I just want, let's put the 2.5. Now if I divide both sides by ln 50, I'm going to get x is equal to ln 2.5 divided by ln 50. And of course, if we put that in our calculator, we'll get our answer. So we have ln 2.5 divided by ln 50 equal, this looks as if x is equal to 0.234. So I'm willing to entertain the idea that I might be wrong, but we can maybe go back and look in the book later on. But I got 0.234 for x. Let's have a go at example 45, which is similar to example 44. I'm going to have 12e to the x squared minus 13e to the x plus 3 is equal to 0. Now, if I call e to the x a, I'm going to have 12a squared minus 13a plus 3 is equal to 0. Now, 12 times 3 is 36. 2 factors of 36 to give me 13. Let's see if I can find any. I think 4 and 9 will probably do it. But let's go. 4 and 9. Or maybe not. Let's see. 2, 18, 2, 9, 3, 3, 3, 1. So 9 and 4 will give me 13, but yeah, I think 9 and 4 would actually work. So if I have 12a squared minus 4a minus 9a plus 3 is equal to 0. 4a is common. We have what? 3a minus 1. Over to the right, 3 is common. 3a minus 1 is equal to 0. So 3a minus 1 multiplied by 4a minus 3 is equal to 0. So 3a minus 1 is equal to 0, or 4a minus 3 is equal to 0. Therefore, a is equal to 1/3, or a is equal to 3/4. But if you remember, we're basically not finished because a is actually e to the x. So what we have is e to the x is equal to 1/3, which is possible, and e to the x is equal to 3/4. If I take log to the base e of both sides, I'm going to get what? X ln e is equal to ln 1/3, and x ln e is equal to ln 3/4. ln e is actually 1, so x is equal to ln 1/3, and x is equal to ln 3/4. I can put these in my calculator to get x is equal to ln 1/3, which is minus 1.10, and x is equal to ln 3/4. Let's find ln 3/4. And this is x is equal to minus 0.288.